Hey, what's up guys? My name is Cherno. Welcome back to my Game Engine series. So last time we took a look at vertex arrays. Definitely make sure that you check out that video if you haven't already. And our kind of application was almost up to the stage where we didn't actually need to call any kind of raw OpenGL calls in order to render our little rectangle and triangle onto the screen, which was pretty exciting. However, the last thing that remained was probably the most critical part of the whole thing, and that is the actual draw call. Now, what is a draw call? Well, to put it simply, it's just a call to actually draw something onto the screen, right? It's our command where we actually tell the graphics card, I've given you a bunch of information, I've bound a shader, I've told you how to do things. I need you to actually go ahead and run that vertex shader with this kind of geometry bound and actually run this pixel shader, this fragment shader, to work out the colors of every pixel on the screen. I want you to actually do that. It's the actual draw command, right? That is called a draw call. Now, in this case, our draw call is GL draw elements, right? There's a bunch of different ways to actually dispatch draw commands, but we're using GL draw elements. And that's the actual piece of OpenGL code that is still inside our actual application. Now, we want to get rid of that. But to do that properly and not just hack it in, we need some sort of renderer, right? And in fact, today what we're going to do is we're going to talk about this entire kind of rendering architecture. And I really want to actually discuss this properly with diagrams. I'm not going to do that today because I'm just going to show you guys the practical implementation of everything. It'd be far too long. The video will probably be about an hour long if I was to actually discuss both the theoretical kind of how this is going to work and draw diagrams, and then also kind of write all the code for it. So this is going to be the code part of it. If you guys are interested in the actual kind of renderer, specifically renderer to render API to render command, that kind of architecture in Hazel, drop a comment below. I'll probably make a dedicated video just talking about that. Probably like a midweek thing. I'm not gonna just take over the main episode just to kind of explain this. I want to maybe make a midweek thing, just an extra video really that will kind of supplement this. So let me know if that's something that you're interested in. Before we continue, just want to thank all the patrons that make this series possible. Patreon.com/thecherno. Huge thank you to all of those people because the series just wouldn't be here without you guys. If you go ahead and support the series, you'll get a lot of kind of perks, such as getting videos early, like a week early usually. So when a new episode comes out, live on YouTube, you can already see the next one straight away on Patreon. So it's you're just a week ahead of everyone else. And then you also get access to the private development repository, in which I already have a full renderer and a bunch of other cool things. I think this week I've added animation to this, so that we have animated meshes, and I've added a material system. It's pretty exciting, and it's kind of, I'm just working on that basically just as a little hobby project, I guess, just as fast as I can, and all that stuff. And there's even a roadmap. I've set up a GitHub project on that private GitHub repository. There's a GitHub project with tasks I'm currently working on. It's kind of a real software development team. So it's really cool. Definitely check that out and help support the series, because that's how we can have these videos for free, which is amazing. Okay, we're going to dive into this. As I said, not going to talk too much about the architecture. You'll kind of see it through the code, I think. So rather than me kind of explaining to you how it works and taking a long time to do that, I want to just really get in and start actually writing code. Before I do that, I will give you some theoretical knowledge though, because I'm trying to teach you guys, not just show you, not just write code in front of you. So basically what we need is a renderer. So what does a renderer do, right? Let's think about rendering a triangle. What do we actually need to do to render a triangle, right? And don't just think of this as a triangle, think of it as some piece of geometry, right? So let's just make the world 3D for a second in our minds and think about a cube. You want to render a cube in your 3D world. What do you actually need? Well, there's a few components that I can think of, right? To actually render something, we know that we need a vertex array, which is something that contains the vertex buffer and the index buffer, right? Or references to those two. We need a shader, otherwise we have no idea how to do stuff. And I think that's, at minimum, that's pretty much it, right? I mean, we need to clear the screen every frame, but that's kind of just details that we don't really care about. Now, a cube in a 3D world. Well, where are we in relation to the cube, right? How are we looking at the cube? That's a camera system, right? So we need a camera. What is a camera? A camera is just a projection matrix and a view matrix, right? Those two pieces of information we absolutely need in the form of a camera. We also need the actual position of the cube in world space, right? So where in our 3D world is the cube actually located? How is it rotated? How does it sit? We need the whole transformation matrix of the cube. That's really important. If we're talking about more advanced details of a more complete renderer that we will eventually have here, we also need to know what surface material the cube has. So what's the cube made out of? Is it wooden? Is it plastic? How reflective is it? How is it textured? All of that kind of stuff. We need to know the material of the actual cube. We also need to know information about the environment, right? So we need to know what lights are in the environment. Is there sunlight? Is there a huge like directional light coming from somewhere because we're outside and that's our sunlight? You know, what does the world look like? Do we have like an environment map, some kind of like radiance map that basically just describes the environment around us? Because that's really important for things like image-based lighting, which we'll be using in the future, right? We need all of that information. And hopefully the way that I've kind of described to you, it starts to separate into two different things. Stuff that's concerned with the environment and stuff that's concerned with the actual like object that we're rendering, right? Those are the two kind of important things. So again, environment, what is that? That's our lighting environment. So where are our lights? You know, is there a bunch of point lights? Is there like a big directional light? That stuff, right? As well as the cube map that is our environment that we need for any kind of reflections, right? To do with that. And we need that for rendering like physically based materials, right? Those two things. And then our camera, where are we looking in, right? That kind of stuff is based on the environment. And you can really start to differentiate it that way, because if you think about it, what if I want to render 2 cubes, right? I want to render a whole scene of objects. Well, what do I need for that? Do I need to, for each object, like update the environment map or the light setup or the camera? No, I'm looking at the scene from one camera. All the objects are going to be rendered with that same set of parameters. That's how you know what belongs to the actual scene. That is what we need to do when we tell our renderer we want to begin a scene. So we'll have a command that's like renderer begin scene, right? Begin scene needs all that information. It needs to know about the environment. It needs to know about the camera, right? That stuff needs to be set up. And the environment includes the lights in this case. Then we have the object, per object kind of basis, right? So I want to render 3 cubes, or I don't know, maybe I've got a level and I've got like walls and I've got like characters, all of that stuff, right? The things that I primarily need for that are materials. So what material is that actual object using, right? How do I render it with what material? And then the second thing is, what was the second thing? The transformation of the object, right? So where in the world is it, right? Those are the two important things that we actually need. And based on everything I've described here, you can render a 3D scene, like no problem at all, right? Done, right? You need that kind of stuff to actually make that happen. So what we're gonna do is we're gonna focus, we don't have any of this yet. This is all conceptual, right? We don't actually have a camera system. We don't actually have a material system. We don't actually have lighting or environments, right? We will in the future, definitely, but we don't right now. But we're gonna still lay the foundation for all that kind of stuff. And it's important to understand the big picture, because I don't want to sit here and give you some kind of like really entry-level basic beginner's tutorial that's just like, oh, you know, we're going to render a triangle this way. No, I'm looking at the big picture. I've written game engines before. I've worked on AAA game engines before, right? I know how they work. And this is me kind of taking a look at the whole holistic view of things and laying this kind of groundwork so that you understand that a render is a bit more complicated than just like, hey, let's submit this thing. But on the other hand, I'm trying to make it simple enough so that I can squeeze this whole thing into like an episode and also not confuse you guys too much and actually see results on the screen pretty quickly. And the object stuff we don't particularly have either. Like transformation matrices, I haven't really talked about them yet. We will in the future, but it's just important you understand that distinction between what's part of the renderer and what's part of the actual object thing, okay? So what we're gonna go ahead and do right now is actually write that kind of renderer begin scene, end scene. So the way that this is gonna flow is we basically say, hey renderer, I'm beginning a scene. That's where we supply all the renderer stuff. So the camera, the environment. Then we render all of our meshes. Each mesh that we render is going to be at a different transform usually. So we'll take in some kind of transformation matrix so that eventually, obviously that'll make its way to to the shader, and that's how we actually transform something, right? That's where all of our meshes go. And then finally we have an end scene, right? That just kind of signals that this scene is over, right? And then usually what happens is all of that stuff doesn't get rendered immediately. It just gets submitted into a render like command queue essentially. So we create a render command out of it and we submit that, right? And we kind of just take our time to submit the whole scene. I ended up explaining everything in this episode anyway, but I would love to do it more in depth anyway in a dedicated video. But the point is we take all this time to submit everything to a render kind of command queue, right? Which again could be later evaluated on a separate render thread. Right? That's what a multi-threaded game engine actually does. And that is actually what we're going to do in the future, right? But we're going to create this kind of command queue, right, of commands that our renderer has to fulfill. We take our time to submit all of that. And then when the whole scene has been submitted and we actually know what makes up the whole scene, only then do we render it. Why? Because guess what? When you have the full big picture of your scene, you can really heavily optimize it. You can just just cull things that are outside of the view frustum. You can decide which objects have the same material so that you can batch them together. You can do really cool kind of optimizations, sorting, all of that kind of stuff that needs to actually be done. You can only do once you have the whole scene. So you can't just go ahead in immediate mode, just render everything as soon as it comes in. That's what we're going to do today, because that's going to be the quickest way to do this. But very soon we're going to restructure this thing and we're going to kind of build this renderer so that it actually works like a real renderer. And that's going to be super exciting. Anyway, enough talking. Let's jump in and create this whole renderer thing. And I'm going to show you how it interacts with OpenGL, because obviously we need to actually dispatch that draw call, and that draw call is GL draw elements, which of course is OpenGL specific. In DirectX, we'd be like calling the context or the driver, whatever, and then being like draw indexed. And then that would be doing its own thing. That's the equivalent of draw elements in DirectX. But here we're just dealing with draw elements. Let's go ahead and create this whole renderer thing. And yeah, this is the beginning of something big, so that's really cool. Let's go ahead and jump into the code. Okay, so this is what we had last time. It's important that we have this because this is our reference. It should look exactly the same, right? So what we need to do now is go into application and just think about the API. That's what I like to do first of all, right? So we have this clear color and we set it, and then we clear our buffer, which is great. We bind this kind of stuff and then we have our actual draw call. Now what I'm going to do is, at the beginning, what we're really going to do is call renderer begin scene, as I said, right? And this is going to actually like dispatch, like it's going to start that scene that's going to contain all of the information about the scene, right? So essentially what we're dealing with here is a camera, lights, and then environment. And you could probably argue that environment is actually, or lights are actually part of the actual environment, right? But that's essentially what a scene needs to have. And in the future, we might just have a struct that is essentially like our scene settings or our scene setup or whatever you want to call it, right? But for now, we don't have any of this. I think maybe in the next episode or so, we're going to probably talk about cameras, because that's going to be one of the most important things. And there's also no way that we can begin a 3D scene, building a 3D scene without actually having a camera set up that we can control with like the mouse. So that's going to happen soon. We'll have an end scene, right? Which signals that this scene is kind of, that's it. That's the end. We're done submitting to this scene, right? And then in the middle is where we kind of submit our geometry, right? So we could have something that's called submit, right? And then we can maybe just submit a mesh. You can call this function submit mesh. You can call it submit geo or submit geometry, right? You can call it whatever you want. I'm just going to leave it really simple and just call it as submit. The reason I can just leave it as submit is because, obviously we're dealing with C++, we have overloaded functions. So based on the type that we actually submit, we should be able to easily discern if this is like a mesh, or if it's, in this case, we're just going to submit a raw vertex array. But that's kind of how that works, right? And then usually what will happen, of course, is this kind of shader stuff that's associated with this, right? That will be inside a material, and the material will be like a mesh will have a material, right? We don't have meshes yet either, but when we do, they'll have materials, right? So when we kind of submit this, that's kind of, this shader is inside the mesh, that's inside, it's inside the material, it's inside the mesh, right? So that's how we kind of get access to it in a more complete kind of renderer. Okay, and then finally, usually what we do is at some point we flush the renderer. Now, usually this is done on a separate thread if you're talking about a multi-threaded game engine design. But for now, obviously we don't have any of that. We don't even have a real render command queue, and we'll talk about that later because again, we need to submit everything into basically a buffer that can then be executed on a different thread. So we'll talk about that later. That's going to be a huge thing that we do in the future as well. Okay, cool. So that's it. So obviously the thing that I want to submit is my square VA, and I still need to bind my shader right now because that's not actually done yet. So what I do is I begin my scene, I bind my shader, and then I render my vertex array. And then I'm going to do the same thing for this. So I'm going to bind this second shader, right? And then I'm going to render this second vertex array. So I'll copy this submit call, and this time I'll submit this vertex array. And that should be it. Now, in terms of this kind of stuff, this clear color, this is going to live somewhere else. So the renderer is the high level class, right? A renderer is an actual, like it's a full-on renderer, right? It doesn't deal with things like, oh, let's clear the screen. That's beneath it, right? It deals with things like scenes and meshes and high level constructs. So what we need to do for here is actually, well, it depends how you want to word this stuff. Obviously terminology is different. I like calling it render commands. So render command clear, right? And then for the clear color, we'll do render command, set clear color, for example, right? Again, you could construct this however you like, right? So what you could actually do is say that I want to clear with a specific color and then just pump that in here. We're just going to set the clear color like that. Setting the clear color is not something that's done that often anyway. Usually you don't really care what color you clear to because you'll be rendering everything on top of the clear color. You should never really see the clear color. In fact, I'd probably argue that a good clear color would be like magenta or something really offensive so that you know that, oh my gosh, like I'm rendering past my geometry into the clear color. That should never happen. Because you should always have like some kind of skybox or environment map anyway, if you have a big 3D scene. All right, that's it, right? This replaces all of the code that we have here, right? So now let's talk about implementing it. So we already have a renderer, and we have a renderer API, but this is going to get slightly restructured. We're going to actually create a renderer API class. Now, this, you could call this render API. There's a huge like school of thought here. I mean, it could be like renderer API or render API. Usually a lot of people call it render API just because it's easier, but I like to actually call it renderer API because it's not like, what is render API, right? This is the API for the renderer. It's a bit of a different thing. So I like to be a bit more specific, I guess, and deliberate with my naming. So renderer API is going to be a class that is going to be, again, implemented depending, it's going to be an interface, it's going to have an implementation per platform, right? Per actual like physical like rendering API, right? So we'll have one for OpenGL, one for DirectX. Now what we actually need to have in here is the actual API, right? So the actual API type we're currently storing inside, and I don't know where that renderer file disappeared to, let's just move it here. This kind of stuff, right? So we need to have this enum class. I'm just going to call this API, and this is going to be what API we're using. So none or OpenGL at this rate, right? I'll make another little public divider here just because I like to have types at the top, then all the public functions, then like all the, private like methods, and then after that, the private members. But anyway, we have this API type up here. This is, again, going to be something that's going to be just an interface, right? So virtual void clear, right, equals 0, right? And again, we could deal with like const and non-const. I don't think that's necessary. It doesn't really matter. This is never going to have const or anything. It's a renderer API. It's just a series of commands. It doesn't really matter, especially with OpenGL because it doesn't have state. So I'm not going to bother kind of decorating names with that stuff just for now at all. Virtual void set clear color. We have a nice math library. We might as well use it. So I'll include GLM, and I'm going to just use const GLM vec4, because we'll probably end up defining colors like that in the future anyway. So that's going to be there. And then finally, we need our actual draw call. So virtual void draw indexed. I'm going to call it the same way as DirectX calls it, because elements, I don't know, draw elements is great, but we're calling it an index buffer. So we might as well call this draw indexed. And again, for now, this is going to take in a const shared pointer, definitely not that. That's going to be our vertex array. All right, and we're taking this by reference just because we don't need to increment the ref count at this rate, like at all, really. Vertex array, because we're not actually taking ownership, we're just reading it. We could make this like a weak pointer if you really wanted to, but that's just needless. We'll just leave it as that, and then we'll just include vertex array, okay? And that's gonna obviously be equals 0 as well. Okay, so that's our kind of renderer API. Now what we actually need is this stuff. So we need to have a private static API, S API, right? This is gonna be our static, what API is actually active at the moment. And then we're gonna have an inline API get API, right? And that's just going to return S API, and that's going to be static, of course. So we'll have to make a CPP file so we can contain this API definition. So we'll call this renderer API.cpp. We'll include our PCH. We'll include the actual renderer API.h, namespace Hazel. And then I'm just gonna copy that equals renderer API OpenGL, because that's the one that we're using, and then we'll just stick this namespace everywhere. Okay, cool. So that's it. That's actually all we need here. That's the render API that's selected. Obviously, we need to have an actual API, right? But that's going to be something that's actually going to be stored in our renderer when it wants to dispatch commands to the render API. And specifically, that's probably going to be inside the render command class that we actually need. Now, I'm not sure if we should create this in the same class as the renderer. I would say no, just because it's going to get pretty big. So what I'll do is I'll create a header file that's going to be render command.h, right? And render command.h is going to be our actual raw render commands. So render commands are going to call into this API and actually, okay, let's delete this for one. And also this. We can still have get API, by the way. I'll just include, I think render command, which will include render API. We'll still have these commands, right? We'll still have this get API function just because it's useful to ask the renderer what API it's using, but this will be a bit different. It'll be render API, get, and then get API will just return this render API that we have here. Oh, this is different, isn't it? This kind of becomes the same in a way, because the renderer will have access to actual render commands. So it'll just end up being render API, get API like that, right? And this, of course, will not get stored. So we'll still have that there just because we still need to be aware of the API, and then we'll have to go into all of our APIs and actually fix that. Should be pretty easy. Really, all we're doing is just adding that. So if I copy that and paste it everywhere, and I think we also need to do it for our vertex array. Okay, done. And that's the only change we have to make just to refactor that. Okay, cool. So back in the renderer, we're going to have all of our actual functions, right? And I'll set these up before I set up the render command just so that you kind of know how it works, I guess. So static void begin scene. And again, to do, right, we'll take in all of our kind of like scene parameters that we need, but for now we'll have nothing. We'll have static void end scene, right? I'll put them close together. And then we need our actual like submission, right? And again, after we have submission, we'll probably have, and I'll take in a const shared pointer. It's our vertex array, just like in the render API. And this will be our vertex array. Okay, that's pretty straightforward. In this case, what you could do is just immediately dispatch it to the actual render command that you actually have. But, you know, I mean, I'm not going to do that because this has to be a proper implementation for the future, right? But if we look at what this function is going to do, and what I'll do actually is I'll make sure we've got a CPP file. I'll delete this old code. I'll just use Visual Assist here to just create all of the implementations for our functions. Done. Begin scene is going to do nothing for now. End scene is going to do nothing. In the future, as I said, you know, begin scene takes all of our scene parameters. What does it need to do? It needs to make sure that the shaders that we're using basically get the right uniforms. And those uniforms are going to be things like which environment map we're using, so which cube map to sample from. It's going to be like the camera kind of details, like the projection matrix and the view matrix, where the camera is in world space, any calculations we might need for lighting and stuff like that, right? So that stuff is going to be set up in begin scene and eventually probably stored in the current scene so that when you render something, it can submit that kind of stuff into the shader. It can upload that data as shader uniforms, right? So that's what it's going to do in the future. Right now it does nothing because we don't have any of that. Submit is the only thing that we do. And what does it do in this case? Really simple. It just says render command. Well, again, what it's actually going to do, right, is it's going to submit it into a queue, right, into like this render command queue. And then eventually that render command queue is going to get evaluated probably on a different thread and it will get rendered, right? But for now, again, we're doing this really easy, the easy way, right? We're just saying render command draw indexed, right? And it's just going to take in that vertex array. Okay. So render command draw index doesn't exist because the render command class doesn't even exist yet, but it's going to. Now render command, this is where it's interesting. What's going to happen in render command is it's going to have a renderer API pointer, right? S API. Renderer API, I'll call it, right? And this render command is going to be real simple, right? This is almost like a static wrapper for the actual implementation. So in this case, what render command is going to do is, again, we have a command called draw indexed, which takes in a const shared pointer of vertex array, right? So we'll put that in here. We can even make it inline because it's a real simple function. And it's just going to say s renderer API draw indexed, and in this case, vertex array. That's basically what it is, right? It's just a little, and again, it's inline, so it shouldn't be an extra function call or anything like that, right? And even if we didn't mark it inline, I'm sure the compiler would, if you compile in release mode with optimizations, with sufficient optimizations turned on, right? And then that just lets us write code such as that, which is really like cool, right? And just make sure that we obviously make this a static void. And this has to be static, and we actually have to implement this. So we'll create a render command .cpp file, which will include our PCH, of course, and our render command header. And then we're just going to set this to be, and we have to create the OpenGL one in a minute, of course, because that's going to be our actual code. But this is going to be new OpenGL renderer API, right? And this will, of course, include that, which is going to be in Hazel/platform. And I actually can't remember if platform is inside Hazel. I never can. It's not. Okay, so it's going to be in include plat. Yeah, it shouldn't be because it's not part of the API. Platform, OpenGL, and OpenGL renderer API. That's where our raw kind of OpenGL calls are really going to go. So right now, inside platform OpenGL, I'm going to make that file. So I'm going to right click here, go new item. We're going to have a header file. It's going to be called OpenGL renderer API, and then we're also going to make a CPP file that's going to be our CPP file. Will include our PCH. We're creating so many files, but you guys kind of get the idea. Hopefully this isn't too annoying. We'll include, renderer slash Hazel slash renderer slash renderer API.h, right? Namespace Hazel. And then we'll have our class OpenGL renderer API, which will be a renderer API, right? And then this is going to be really simple. We're just going to grab all of this stuff and implement it, right? Easy. So we'll get rid of the equals 0 and add an override instead. And again, I'm just going to get, let's just put namespace Hazel into the CPP file. I'm just going to get Visual Assist to generate the stuff for us, nice and simple. Okay, cool. So guess what this stuff's going to do? It's actually going to run our code. So we need to include glad, right? Set clear color is going to call GL clear color, right? With color.r, color.g, color.b, color.a. Right? It's the same as XYZW, right? GLM just gives us multiple kind of aliases for the same variables that we can access, which is nice. GL clear, we'll just do GL clear again. This stuff is, quite temporary because a lot of the times you don't want to clear both the color and the buffer, and you don't want to clear both the color buffer and the depth buffer. But for now, again, really simple, really primitive. In the future, we'll probably take in flags as to what you actually want to do, what you actually want to clear. And also this clear command is probably something that frame buffers will actually end up calling, not just like inside our loop like that. Draw indexed is going to do our GL draw elements. Again, for now, we're just drawing triangles because we have no idea what kind of primitive like type we actually want to draw at the moment. It's just triangles for now. Count is going to be vertex array dot get index buffer, right? Index buffer get count. GL again, we've only got one type of index buffer right now, and that's a unsigned int. And then the pointer to the indices is going to be null. Okay, so there we go. That's our draw call done. Okay, and now inside, obviously from our actual interface, right? Sorry, not from our interface, from render command. I'm getting a little bit lost here because this stuff there's tons of this stuff, and it's not even showing up in my searches, which is fantastic. But inside render command, you can see that because the API at the moment is set to be OpenGL render API, and I'm not sure why this stuff is not working. Render API inside, sorry, it's just inside render command, obviously. So because it's set to OpenGL render API, right, when we actually call draw indexed from a render command, it's going to dispatch it to that, and that's just going to work, right? Obviously in the future, this kind of stuff will be set dynamically, not just equals new OpenGL render API. When we start up our application and we create the right context, it's going to actually specify which render API it's using by creating like a new OpenGL render API. Okay, cool. And yeah, obviously don't worry about like memory leaks or anything like that. This is a pointer that's going to last the entire lifetime of our whole application. And also it's a pointer to a class with no members. So it's a 1 byte memory leak, if it is a memory leak, right? And I guess it's just 1 byte of memory that we're never going to clear up until the end of our application because it never needs to be cleared up. So please don't worry about that. Okay, cool. I think this is almost done. I don't even remember the code that I've typed. So if we go to renderer.cpp, yeah, I mean, draw indexed, right? We dispatch that, and I think that should be pretty good, to be honest. So if we go back into application, what I should be able to do is just include the actual renderer, what is it? Hazel renderer, renderer.h, right? If that's not already included, which it totally might be. Anyway, we'll include that, and then instead of doing all of this, you know, we should set our clear color. I guess we can set it to the same thing that we had it as before. Here we were just clearing the color buff a bit. Now we're clearing both color and depth, which is good. So we'll pop that in there. So apparently it doesn't have, does renderer include render command? Because if it does, then yeah, it does. So we should have access to that. Oh, render command doesn't have that. Oh, render API does. Yep. Of course, we need to actually make those functions. So this set clear color and everything that we have here, we'll copy this, we'll paste it here, and we'll kind of change it a bit. So this becomes inline static instead of virtual, right? And then obviously the implementation of this is just going to be dispatching it to the render API. So render API, clear, and this becomes render API set clear color, color, okay? And then back here, that should now work. So we have our clear color. We'll just put curly brackets around this to create a vec4. And then, I mean, instead of, we don't need any of this code anymore. So we've just got kind of, we begin our scene, which you could even, if you wanted to, you know, you could even put this into a scope just so that you're kind of clear as to when you kind of begin and when you end, maybe something like that. I'm not going to bother with that, but some people do that just in case it helps you. You can do that if you want. But we have begin scene, we have end scene, and then we actually draw our scene, right? So we bind the shader, we submit the vertex array, which should bind it. Oh, that's one thing I didn't do. I didn't bind my vertex array. So the renderer, right, when it submits this and says, let's draw indexed, what it should do is actually bind the vertex array, obviously, and then actually issue the draw command. This is a render command. Render commands do not do multiple things, right? Unless they're like maybe specifically supposed to, right? Render commands do not do multiple things. What that means is that you do not, like, for example, be like vertex array bind here. No, this just draw index. All it does is draw index. It doesn't bind anything, doesn't do anything. It's a plain old vanilla render command. So the renderer is in charge of abstractions such as being like, bind the vertex array, bind the shader, set up the materials, do all the sorting, that kind of stuff, right? Because it's much higher level and that's what it operates on. Okay, our scene should now work. Let's hit F5 and see what happens. I really need to make some t-shirts with that on it. Coming soon. Okay, and once our code compiles, you can see we get the exact same result, which is pretty awesome. Okay, so that's that, right? Theoretically, what we can do, hopefully, is actually just get rid of glad here. So we're not going to include glad anymore. We're not including it in the header file either, right? If I hit Control F7 to compile this code, it works, right? Beautiful. So we don't need glad anymore. We're just completely using Hazel's own API to actually render this stuff, which is pretty cool. For homework, what you guys could do is remove this code from the application class that's inside Hazel and move it into Sandbox, because we should really start doing that. And I'll probably do that in the next episode. But that'll be a nice little exercise. You'll have to move all this vertex array stuff, and hopefully like it works cross module and it links properly. It should. Everything should be great. And that's that. That's pretty cool. We have the beginnings of our renderer. Anyway, I hope you guys enjoyed this video. If you did, you can hit the like button. As I said in the beginning of the video, you can help support this series by going over to patreon.com/the Cherno. Huge thank you, as always, to all the people that make this series possible. Next time, we're going to talk about cameras, because this is all great that we can render a bunch of objects on the screen, but there's two things that's missing from this, right? as I said, we don't know where we're rendering the objects. We're not supplying any kind of transformation matrix. We need to do that. And then the other thing is we need to actually supply a camera so that we can move the camera around and do all of that kind of fun stuff. So we're going to talk about cameras next time. And then after that, I'm not sure. Next time we'll either talk about cameras, I haven't decided yet, or we'll talk about the actual transformation matrix, right? And how to actually tie transforms into primitives that we render onto the screen. Because the way that kind of works is that transform actually needs to be uploaded to the shader. So in that sense, it needs to know what shader you're rendering with. And to do that properly requires a material system. But obviously there's a way for us to do it kind of quickly. And we'll probably do that so that we can actually start having stuff on the screen. And that's going to be really exciting because once we have that kind of stuff, we can just, once we have a good camera system and ways to kind of submit, begin a scene with a certain camera and submit objects with different transforms, we can actually start building up a scene. Those are the main building blocks we need. And then from there, we can start rendering an actual 3D scene, which is ultimately where we're kind of steering towards. But, there's other stuff we can do along the way, like textures. Because that's kind of a 2D thing anyway. So we can, we're drawing a rectangle right now. Why not texture it, right? So we'll have to deal with that at some point. And then there's other things that I don't really want to do now, but we should, but it just slows us down and it's very complicated. But basically that kind of render command Q and multi-threading our renderer. That stuff we'll probably do in the future once we actually have a 3D scene to play around with, because that's more of an optimization that's no way going to be a bottleneck at this point, and it's just going to further complicate our code. So I'd rather kind of do the other stuff first. Anyway, let me know what you guys think, and I will see you next time. Goodbye.